Hey guys, welcome back. This is part two of finding volume using the shell method. This is going to be example number two that we're doing, and here we're given a different function. We're given different boundaries, and now we're going to be spinning it around the x-axis, okay? Revolving, spinning, same idea, okay? So let's take a look at this. We have all of our criteria here. We're going to graph to get a good picture of what this guy looks like, okay? Obviously, just like to label some of these things. And we're looking at the square root function, okay? And we could see here, the square root function we know is going to start at 0, 0. It's going to come out here, okay? This would be bounded by y equals 4, which is a horizontal line at 4. Okay, obviously this isn't to scale, but we'll call that 4. Okay, and those are all the pieces we really need right now. If we wanted to find this point, we could take 4 and we could set the function equal to 4. We square both sides and we get 16. So we know that this coordinate would be 16 comma 4. It's really not going to come in handy. We're going to be revolving this guy, as we said, around the x-axis. And since that is horizontal, our representative rectangle has to be parallel to that. So that would be an example of a representative rectangle. That tells us everything isn't going to be in terms of y, because this thickness would be dy. The radius here would be the distance from our axis of revolution to our representative rectangle. And the height now is our length, which is basically the function. However, we want everything in terms of y. So the first thing I'm going to do is just show that our function, which is y, equals the square root of x. If we square both sides, we get y squared equals x. Okay, so here's our radius. Our radius is going to be y. Our height in terms of y is going to be y squared. Okay, and now I'm ready to begin. I'm going to find the volume. We're taking our constant, we're pushing it out. Everything is in terms of y, so our boundaries are going to be from 0 to 4. Okay, again, finding 16 wasn't important here. We know that if we were going to be using a different method, it would be. So that's just helpful and mindful to be mindful of. Okay, but now we need to have our radius, which we set up here is y, times our height, which is y squared, and that all is in terms of y. Okay, so we're going to clean this up just a little bit before we do any calc. Y times y squared is obviously y cubed. And now we're ready to integrate, and then we'll evaluate. So I'll keep 2 pi out front. We're going to add 1, multiply by the reciprocal, and we're going to evaluate that from 0 to 4. Okay, so I'm taking 2 pi, I'm keeping it out front, I'm plugging in. It's always the upper bound minus the lower bound, and when I plug in 0, 0 cubed times 1/3 is obviously 0. So here we have 64 thirds. Uh, 64, so we added, I'm sorry, that was a 3. So we're going to actually make that, oh, I said it, but didn't do it. We're going to make that a 4. There we go. Knew it wasn't looking right. So this becomes 64. 64 over 4 is 6. 64 divided by 4 is 64 times 2, I believe, is 128 pi units cubed. And this should be to the 4th as well. There we go. All right, just checking the work over. A little sloppy, I apologize, but there we go. And that would work and give you 128 pi units. I think you guys get the idea there. All right. So our last example here, we're going to be taking this function again. Now this is important. We're revolving it around the line y equals 8. Okay, so the same idea follows. We're just going to have to be a little bit more creative with finding the things we need to find in order to use the shell method. Okay, so we have x minus x squared, and that's bounded by the x-axis. Okay, so this is a quadratic. It's opening down. If we wanted to see where it's going to cross here, it might be a good idea to just take this guy, set it equal to 0. We can solve by factoring out an x, and I end up with x equals 0 and 1. So we're going to have a quadratic that's going to cross at 0. We'll call that 1. Okay, and here's our region that we're going to be rotating around the line all the way over here. We'll say x equals 8. That is our axis of revolution. Okay. So let's get started with it. We first draw our representative rectangle, which is going to be parallel to our axis of revolution, which is all the way over here. That tells us everything is going to be in terms of x. This is our dx here. Okay, so first thing we're going to find is the radius, and the radius is going to be the distance from our axis of revolution to our representative rectangle, okay? And that has not changed. We've been consistent with that. If you look back in the first two examples, you'll see that's what we did, okay? And we got to find that distance. So this is where we got to be a little creative here in order to find what r is, okay? We know that the distance from here to here, guys, is 8. And the distance from here to here is x. That'll change, obviously, where we draw our representative rectangle, so we'll call that x. So if we take 8, we subtract x, that would give us r. Okay, again, so this is x from here to here. The whole thing is 8. So if we take 8, subtract x, it leaves us with r, and that is our radius. Okay. We know the height of this is going to change, and it's going to be the function itself. The height in terms of x would be x minus x squared. Okay, so now we have everything we need. We can come over here. We're going to set up our integral, which is going to be 2 pi. We're going to run it everything in terms of x, so it would be from 0 to 1. And it's going to be our radius times our height with respect to x. So we're just going to use some old-fashioned algebra. We're going to FOIL this guy. First, outer, inner, last, and that gives us 8x minus 8x squared minus x squared plus x cubed with respect to x. Now we're ready for some calculus. Okay, we're going to integrate, adding 1, dividing by. Actually, before we do that, it might make sense to combine like terms. So we'll combine like terms and clean it up. And I like that. Okay, so now we have 2 pi. Now we're going to integrate, add 1, divide by 2, add 1, divide by 2, and add 1, divide by 2, and we're going to run that from 0 to 1. Okay, so we'll keep this idea here. We got 2 pi, we're going to plug in 1, it's the upper bound. Minus the lower bound, which is 0. And we end up with 2 pi times 5/4, which is 5/2 pi units cubed. Okay, so that wraps up our first lesson, Calc 2, which is the shell method. Hopefully you found that helpful. Feel free to go back and watch this as many times as you need. and I think it went pretty well. If you guys have any questions, feel free to bring them when we meet live, and I'll be posting the homework assignment on Google Classroom for you guys to complete. Okay, and till next time, see you guys later.